Concept 4 is the metric system. Now, most of you have probably heard of the metric system before in another science class, but we are just going to build on top of what you have learned before, okay? The metric system, like all units, are very, very important in chemistry because chemistry is a lab science and it involves a lot of quantitative data. Now, this is as opposed to the qualitative data, okay? Quantitative data would be any kind of data that involves math, okay, numbers. Qualitative data, on the other hand, is description, describing what happens, what does the reaction look like, what does the chemical look like before and after, okay? So make sure that you understand the difference between quantitative data and qualitative data, okay? All measurements in science, including chemistry, needs to be taken in metric units. Now, most of you have heard of or have learned about metric units before. Metric system is the international system. Okay, that's what it is known as generally. Now, it is also known as the SI. Okay, this comes from the French name. Basically, in French, it is known as Système International. Okay, so international system of units. So what this means is SI is understood worldwide. Okay, the metric system is used throughout the entire world, and we are the only major country that doesn't really use metric units. Now, SI makes use of Latin. And if we know anything about Latin, is that it was the language of educated people of Europe for a very long time. Okay, and so we have a lot of science words that were based on Latin. Okay, and SI is one of those. So metric units are based in Latin. We use Latin-based units and Latin prefixes. All the SI unit prefixes are based on multiples of 10. Okay? And that means that we can use scientific notation with metric system. Okay? We are going to talk about a few common units that are used with the metric system, or these are the metric units for something that we measure in the lab. Okay? So distance, we use meter. This is abbreviated as M. It is about a yard. Okay, it's about the same length as a yard. The liter for volume, and this is usually for a liquid. Okay, if you guys know the size of the 2-liter Coke, a liter is about half of that. Okay, mass is measured in gram. Now, gram is a very, very small unit. It is about the weight of a paperclip. Okay, and time is usually measured in seconds. Now, we use S as the abbreviation for seconds. And then with temperature, we use 2 units. There's degrees Celsius, which is the unit that most people in the world use for their weather temperature, okay? And Kelvin, which is symbolized by a big K. And Kelvin is used in science usually for gas laws, okay? And later in the year, when you get to gas laws, we will be talking more about Kelvin. Alright, let's talk about the prefixes. You have probably all heard of these prefixes. Okay, we have kilo, hecto, deca, the base units, deci, centi, and milli. Okay, first thing that I want to do is just give you the abbreviations. So kilo is K, hecto is H, deca is DA. Base units, or the ones, are your meters, liters, grams. Okay, so I want you to write out here that this is the ones. Deci is D, centi is C, and milli is M. Alright? Okay, I'm going to make a little note out here that kilo, this end, of the kilo end of the prefix scale, okay, is the huge part. All right, and the milli end of the prefix scale is the tiny part. Okay, and this can help you later on when we are converting, because then you can think a lot of tiny stuff has to fit into one huge thing, okay? Alright, now let's talk about the base units, or the number of base units in standard form and also in scientific notation, okay? The easiest one to figure out is the base units for the ones. It's one base unit, okay? And in scientific notation, then, that would be 1 times 10 to the 1 power. Alright, I'm going to go up first. Deca, think of decade. A decade is 10 years. So that is 10 base units. And, oops, that should be 0 power, and that should be 1 power. Okay? Hecto is 100. 1 times 10 to the 2nd power. And kilo is 1,000. 1 times 10 to the 3rd power. If you think when people say that they have 5K, that means they have $5,000, right? Okay, so K, the kilo, is 1,000. You can also think of a kilobyte in computer speak. Okay, kilobyte is 1,000 bytes. Alright, deci, we're going to go on the other end now. Deci is 0.1. So in scientific notation, that would be 1 times 10 to the negative 1 power. Centi is 0.01, or 1 times 10 to the negative 2 power, and milli is 0.001, or 1 times 10 to the negative 3 power. Okay, now let's talk about how we're going to convert metrics. You have probably learned the moving the decimal format. Now what we are going to do in chemistry in this class is we are going to use the 5-step method that you learned about in concept 3 to solve SI conversion problems. Okay, you must always convert to or from the base, or the 1. For the conversion factor, put 1 in front of the prefix. Okay, so the prefix unit. So we are going to do a few examples to illustrate what I mean by this. So let's do example number 1. There are how many meters in 2,000 millimeters? So the first step in our 5-step method is just to identify the given. So as always, I'm going to write down given, and my given is 2,000 millimeters. Okay? Second step is identify the answer, and my answer that I'm trying to look for is how many meters. The third step is a conversion factor. Alright? Now, what you need to know is you always have to convert to and from the base unit. And in this case, our base unit is meters. Okay? And you're always going to put 1 in front of the one with the prefix, which is, in this case, millimeter. And then we are going to look on the table of the prefixes and write down what it means for the base unit. So it's 1 millimeter equals 1 times 10 to the negative 3 power meter. Okay, so that's our conversion factor. Let's put it into our dimensional analysis grid now. We have 2,000 millimeters. That's our given. Millimeters on the top, so millimeters must be on the bottom. They must match up. Okay, so 1 millimeters equals 1 times 10 to the negative 3 meters. The millimeters will cancel out. We are going to put this into the calculator. 2,000 times 1 times 10 to the negative 3. Remember, times 10 should be punched in as an E in your calculator. So it will be 2,000 times 1E negative 3. And the answer is 0.002 meter. There you go. That's the answer. Okay, now I'm going to do number 2. Number 2 says convert 5.0 times 10 to the third power milliliters to liters. Okay, so our given is 5.0 times 10 to the third power milliliters. Okay, now I know that this is a scientific notation, but there's no need to freak out about this. They are just a number. Okay, now the answer that we're trying to find is how many liters. The conversion factor, in this case, we are trying to go from milliliters to liters. Alright, now the unit that has a prefix is milliliter, so we are going to put the 1 in front of milliliters, and milli is 1 times 10 to the negative 3, so 1 milliliter is equal to 1 times 10 to the negative 3 power liter. Okay, fourth step, the grid. Again, we are going to plug in our unit, or our given first, 5.0 times 10 to the 3 power milliliter. Okay, we are going to put milliliter on the bottom because they need to match up, top and bottom diagonally, and the top is liters. Okay, 1 milliliter, 1 times 10 to the negative 3 liters. This will cancel out, and we put this in the calculator. So what you would do is take 5.0 E3 times 1 E negative 3, and the answer is 5.0 liters. Okay, now you might be wondering why I put the 0 after the decimal in my answer. We need 2 sig figs because my given has 2 sig figs. Okay, look at number 3. Number 3 says how many milliliters are in 0.006 deciliter. Okay, we are going to start with our given. The given is 0.006 deciliter, which is DL. And the answer that we're trying to get is how many milliliters, which is ml. Okay, third step, our conversion. Remember to always convert to the base unit and from the base unit. So we are going to start with DL, or deciliter, to the base unit, in this case is liters. Okay. The unit with the prefix is deciliter, so we're going to put a 1 there. And deci means 1 times 10 to the negative 1. Alright, if we stop right there, we would get to liters only. We want to get to milliliters, so I'm going to continue on. Liters equals how many milliliters? Okay? Now, in this case, the unit with the prefix is milliliter, so I'm going to put the 1 there, and milli means 1 times 10 to the negative 3 power. Those are my conversion factors. I am ready to do the grid. Okay? 0.006 deciliter is my given. Deciliters on the top, so deciliters on the bottom. That's 1 deciliter equals 1 times 10 to the negative 1 liter. This will cancel out my deciliter. I am now in liters. Liters on the top, so liter will be on the bottom. Okay? And that will be 1 times 10 to the negative 3 liters and 1 milliliter on the top. Liters will cancel, and now I have milliliters. Okay. When you are putting this into your calculator, you will have 0.006 times 1e negative 1 divided by 1e negative 3. And the answer is 0.6 milliliter. Okay, notice that the given has 1 sig fig, so your answer will have 1 sig fig.